Welcome to my channel Learning Electronic Circuits. Here you can learn more about different electronic circuits, its working principles and the construction techniques. Let's go. Electrical nature of atom. All materials on earth are composed of atoms. The atoms contain different types of charged particles. Normally in an atom, positive charge of the nucleus and the negative charge of the electrons are in equilibrium or in exact balance. In some materials, the atom loses an electron and becomes slightly positive. In that case, it is called as a positive ion. While in the other case, if the atom picks up an electron and becomes slightly negative, it is called as a negative ion. Conductors. Some materials give up electrons and move about when an external voltage or potential difference is applied. They offer least resistance to the flow of electrons or current, and the free electrons move from a lower potential to the higher. Those materials which allow electrons or current to pass through them are called as conductors. Examples of those materials are metals such as copper, aluminum, iron, gold, silver, etc. Insulators. In some materials, the electrons are strongly attached to the nucleus. It does not allow the electrons to freely move about when a potential difference is applied. They offer high resistance to the flow of current. Those materials which does not allow electrons or current to pass through them are called as insulators. Examples of those materials are glass, plastic, wood, mica, rubber, etc. Semiconductors. Semiconductors are materials whose electrical conductivity lies between that of a conductor and an insulator. The flow of electrons happens in a semiconductor only when the potential difference given is greater than 0.7 volt in silicon and 0.4 volt in germanium. The current passes through the material only when the P side is connected to the positive terminal of the battery and the N side is connected to the negative terminal of the battery. Examples of semiconductor materials are silicon, germanium, gallium arsenide, etc. Now we are going to look at the different types of conductors. You can see this is a stranded wire, multi-stranded wire. You can see different strands that is going into the wire. This is a multi-stranded wire, and this is a good conductor of electricity. You can see a single strand that has been this is a single strand of wire. This conducts electricity, or it can pass electric current. And this is another wire. This is a 5 amp 220 volt 5 amp wire. We use it for electric wiring. And this is another wire that is 15 amp electric wiring type of wire. These are all multi-stranded wires. You can see different different multiple strands that's been going inside this multi-stranded wire. This is another metal. It's a different. I think it's a tin. It's a tin wire. This is actually copper wire. And these are all DC wires. Small. You can use it to wire small DC connections. This is a small DC wire. This is another similar another wire with similar characteristics. And how do we know that this conducts electricity? We need to know how it conducts electricity. So now just I have a battery here. I'm connecting a crocodile here, and I'm just tying a piece of copper strand here, and I'm just using a filament bulb here, and just using just connecting the other piece, other side of the wire, and closing the contact. You can see the light, the bulb is lighting up, This is an old filament bulb that I had with me. So this proves that this wire really conducts electricity. It just passes electric current to pass through it. So that is how it is. This circuit is completing. Similarly, we can use other wires where you will connect the other end like this, and you can use the opposite end to tie over the bulb. Just contacting it over placing it over the bulb. Now I am placing the other end of the bulb to the other pole of the battery. Now it is brighten up. This is how the full path of electric current has completed, and this creates a the glowing up of the filament that is in the bulb. It shows the flow of electric current through the filament, and that's why it just glows up. So this is one example, and another thing we can do is, these are all coil wires. We are using it to coil transformers and the winding transformers and things like that. These are all enamel copper wire. These are fully enameled. It's there is a coating on the top of the wire, which is a type of enamel coating that doesn't have any outside contact. To prevent any outside contact, it have a enamel coating over it. So now here we have a multimeter that is placed into the position is in the continuity place, and you can see the position here where it's been placed, where we can check continuity. Now we are using this to measure a piece of tinned wire here. Now you can see the beep that is being heard from the multimeter. This proves that it does conduct electricity. When we use it to place both the terminals, we can pass electricity through them, and which does show the continuity. It fully passes the electric current, the small current that is present in the multimeter that you can see there. And similarly, all this multi-stranded wire, the single strand, this can also pass electric current through that, and similarly it beeps up. This shows that these are all conductors of electric current. Here likewise, I'm also introduce another metal here, a piece of metal. It's an aluminum piece. This can also conduct electricity. I can see the beep. This also conducts electricity, and we have another thing here. It's a piece of coin. I don't know whether it's copper, maybe it's a bronze coin. It's a 10 rupee coin. This also conducts electricity. These are all metals, that's why it conducts electric current through it. And similarly, there are a lot of other items like this tweezer. This really conducts electric current. This is a forceps here. This can also have a similar characteristic. It can conduct electricity. This is a similar pattern. This also conducts electricity. Now we'll go through a different type of material here. This is it's an insulator. This is a piece of it's a mica piece. Actually, it's a mica, and it doesn't actually conduct electricity. And similarly, we can also find similar materials like plastic. It doesn't conduct electricity. Similarly, this is a piece of plastic. It too doesn't conduct electric current. So these are all insulators. Now I am introducing another material here. This is a small container filled with water. Let us see whether it conducts electricity. No, I just dip the tips of the probe into the water, and but still there is no conduction of electricity. We don't hear the beep here on the multimeter. So water, it seems like a poor conductor of electricity. Pure water is a poor conductor of electricity, but when you add maybe some salts or some other material, it may start to conduct electricity. So that is how it works. It's a solvent. Water is a solvent where many salts or metal oxides, when it's dissolved in water, it may conduct electricity. Now coming to semiconductor materials, these are materials which partially passes the electricity or electric current or flow of electrons through that materials. It has a conductivity that is between a conductor and an insulator. Now in a semiconductor, when you apply a voltage, it needs a certain threshold, like a particular voltage needs to be reached for that material to conduct electricity, a current. So in a typical silicon semiconductor, it needs 0.7 volt to get the threshold. That is the 0.7 volt that is the threshold to be reached for that silicon material to conduct electricity. So likewise in a germanium, it's like 0.4 volt. When you look at these are all semiconductors. You can see many of those semiconductors. These are different types of diodes. This is a bigger diode. This is another diode. This is another type of diode. This is a smaller one, and you can see a lot different types of transistors. These are all small signal transistors. This is a larger one, which can pass more current. It's a bigger, higher power. It's a power transistor. Likewise, this one also. This is another transistor. There are many ICs also. These are all semiconductors. These are all made of semiconductor materials, either silicon or germanium. So these are the semiconductor materials.